Hey everyone and welcome! Today we are going to tackle one of the absolute first things you need to know in game development: how to make stuff move. Seriously, if you've ever fired up Unity and wondered, okay, how do I get my character to actually walk? Or how do I get this spaceship to fly across the screen? Well, you've come to the right place. We're going to zero in on a super powerful but really easy to use tool called Transform.Translate. By the end of this, you'll have your game objects cruising around like a pro. All right, let's get into it.
So here's the game plan for today. First, we're going to look at a classic problem. We've got an object that can spin around, but it's totally stuck in one spot. Then we'll introduce the hero of our story, Transform.Translate. After that, it's time to get our hands dirty. We're jumping right into the code to get our first movement working. From there, we'll learn how to tame that movement, controlling its speed and direction. And finally, we'll put it all together, combining rotation and movement to create something really cool.
All right, let's set the scene. So imagine we're building a little driving game. We've got our car model in the world, looking great. We've even written a little bit of code already, and we've managed to get it to turn. But that's it. That's all it does. It just sits there and spins on a dime, like a ballerina in a parking lot. It's a start, for sure, but it's not much of a game if our car is glued to the floor, right? This is the problem we need to solve.
So just to be super clear, here's exactly where we're at. We've got our car object in the Unity scene. Attached to that car is a C# script we've called driver. Now inside that script, specifically inside the update method, which runs over and over, we have one line of code using transform.rotate. And the result, as we've seen, is that our car can pivot beautifully, but it has absolutely zero forward momentum. Our main mission right now is to give this thing an engine. Okay, so how do we fix our stationary car? Well, we need a new tool in our developer toolkit. If Transform.Rotate is our wrench for turning, we need a different tool for pushing it forward. And that tool, my friends, is called Transform.Translate. This single command is going to be the key that unlocks movement for us. It's the go button we've been looking for. Before we actually type it out, let's take a half step back and ask, what even is this transform thing we keep talking about? Think of the transform component as the DNA of every object in your game. You can't have an object in Unity without a transform. It's what gives it a physical presence in the world. It holds three absolutely vital pieces of information: its position, which is its XYZ coordinates, basically where it is; its rotation, which is which way it's facing; and its scale, which is how big it is. It's the object's address, orientation, and size, all rolled into one. And that brings us to the key difference here. The two commands look so similar when you write them in code, right? They both start with transform.something, but they do totally different jobs. Transform.Rotate messes with the rotation values of the transform component. That's what we've already used to make our car spin. But Transform.Translate, our new tool, that one messes with the position values. One is for turning, the other is for moving from point A to point B. It's really as simple as that.
Okay, so we're ready. We're going to use Transform.Translate to move our car forward. But hold on. That brings up a really important question. What does forward actually mean to a computer? It doesn't know what forward is in the real world. We can't just tell it, go that way. We have to be incredibly specific and give it directions using a language it understands, which is a coordinate system.
And that language is Unity's coordinate space. Just picture a 3D graph in your head. You've got the x-axis, which always handles side-to-side movement. A positive x value moves you right, a negative x moves you left. Then you have the y-axis, which is for vertical movement. Positive y is up, negative y is down. And then, giving us our 3D depth, you have the z-axis. Positive z is forward, away from the camera, and negative z is backward, towards the camera. These three axes are how we tell any object in Unity exactly where to go. Now this is where you have to put your game designer hat on. In a typical 3D game, like a first-person shooter, forward is always the z-axis. But look at our game. We're using a top-down camera looking straight down at the action. So for us, the player, when the car moves up the screen, that's what feels like forward. And which axis controls up and down movement? The y-axis. This is a huge concept to grasp. Forward for the player is all about the camera's perspective. So for our game, moving in the positive y direction is how we're going to make our car go forward.
Okay, enough theory. It's all well and good to talk about axes and components, but the real fun is in making things happen. We know the tool, we know the direction. It's time to pop open our script and write the one line of code that's going to bring this car to life.
All right, first things first. Let's open up that driver script in Visual Studio Code or whatever editor you're using.
Now, before we add our new code, we're going to temporarily shut off the old rotation code. You can do that by just typing 2 forward slashes right at the start of the Transform.Rotate line. See how it changes color? That's called commenting it out, and it tells the computer to completely ignore this line. Why are we doing this? It's a really good habit. It lets us isolate the new thing we're testing. We want to see only the effect of our movement code, without the car spinning around and confusing things.
Perfect. Now on the next line, still inside our update method, we're going to add the magic. Go ahead and type Transform.Translate, and then open up a set of parentheses. Inside, we need to give it our directions for X, Y, and Z. So, since we decided we want to move up along the Y-axis, we'll type 0, 1, 0. This means 0 movement on the X-axis, move 1 full unit on the Y-axis, and 0 movement on the Z-axis. Then just finish the line with a semicolon. That's it. Save the script, let's jump back into Unity and brace ourselves. Let's see what happens.
Okay, we're back in Unity. I'm going to hit the play button and... Whoa! Did you see that? The car was just gone. It just became a blur and shot off the top of the screen in a nanosecond. If you blinked, you probably missed the whole thing. So, the good news is our code totally worked. The car definitely moved forward. The bad news is it's moving at like warp speed. This is a super common thing to happen when you're starting out, so don't feel bad. Let's figure out why it happened and how we can actually control it.
So that crazy launch wasn't a bug in our code. Not really. It was our code doing exactly what we told it to do. We just didn't fully understand the context in which it was running. So now it's time to refine our approach. We need to understand why it was so fast and then learn the proper way to dial it back and get the smooth, controllable movement we actually want.
And the entire reason for our speed problem is this guy right here, the update method. It's crucial to understand that update doesn't just run once when the game starts. It's a relentless loop. Unity calls everything inside update over and over and over again. How often? It runs once for every single frame your computer can draw on the screen. It's like a super fast heartbeat for your game.
Now let's connect the dots. A pretty standard computer running a simple game like this is probably hitting at least 60 frames per second, or 60 FPS. That means the screen is redrawing 60 times every single second. And that means our update method is running 60 times every second. So that line of code we wrote, Transform.Translate 010, was being executed 60 times a second. We didn't tell the car to move 1 unit. We told it to move 60 units per second. It's no wonder it blasted off into space.
Okay, so knowing that, how can we slow it down? Well, the quickest, simplest fix is to just give it a way smaller number. Instead of telling it to move 1 whole unit every frame, let's tell it to move a tiny little fraction of a unit. So let's change our code to Transform.Translate 0.01f0. That little f on the end is important in C#. It just tells the computer that this is a decimal number, or a float. Now, if we save this and run it, you'll see the car moves at a much more reasonable, visible speed. But this is just a band-aid. There's a much better, more professional way to do this.
The problem with our quick fix is that the car's speed is still tied to how fast the computer is. Someone with a super fast gaming PC would see the car move faster than someone on an old laptop. That's not fair. We need the game to be consistent for everyone. The professional solution is to use this magical thing called time.delta time. This is a special variable Unity gives us that holds a very small number, the exact time, in seconds, it took for the computer to finish the last frame.
This table really breaks it down. Look at the top row. That's our first attempt. It's frame rate dependent. That's bad. It leads to inconsistent experiences. Now look at the bottom row. This is the correct way. We tell the car to move 1 unit, but we multiply it by time.delta. What this does is it turns our command from move 1 unit per frame into move 1 unit per second. If your computer is fast and has a lot of frames per second, delta time will be a very small number. If your computer is slow, delta time will be a bigger number. It perfectly balances out so that the car moves at the exact same speed on every single machine. This is the industry standard way to handle movement. Yes, we've done it. We now have a car that moves forward at a perfectly controlled, consistent, frame rate independent speed. This is a huge milestone. So now, for the grand finale. It's time to bring back our rotation code from the beginning and see what happens when we combine these two behaviors into one fluid motion. This is going to be cool.
Let's head back into our script one last time. All you have to do is find that Transform.Rotate line and delete the 2 forward slashes at the beginning to uncomment it. Now it's active again. Go ahead and save your script. So let's think about what's going to happen in our update loop now. On every single frame, Unity is going to read both of these lines. First, it's going to move the car forward by a tiny delta time adjusted amount. Then immediately after, it's going to rotate the car by a tiny amount. This will happen so incredibly fast, 60 times a second or more, that our eyes won't see two separate actions. We'll see them blend together into a single, smooth curve.
And now for the moment of truth. We go back to Unity, we press play, and look at that. It's perfect. The car isn't just spinning in place anymore, and it isn't just driving in a straight line. It is perfectly combining that forward translation with the constant rotation to drive in a beautiful, smooth circle. This right here is the magic of game programming, taking very simple commands and looping them really fast to create complex, elegant behavior.
Now let's be real. A car that just drives in a circle forever isn't exactly the next blockbuster game. It's not very interactive, is it? But don't underestimate what we've just accomplished. We have mastered the absolute fundamental building blocks of movement in Unity. Almost every action in every game, from a character running to a bullet flying, is built on these core principles of manipulating a transform over time. We are absolutely on the right track.
And that leaves us with one final exciting question to think about. We've basically built a self-driving car. It has an engine, it has a steering wheel, and it follows its own simple instructions. But to make this a game, we need to hand the keys over to the player. So how do we listen for input from a keyboard or a gamepad and use that to control the movement and rotation that we just built? That is the next big step in our journey, and it's exactly what we'll be looking at next time. Thanks so much for joining me today.